Let's try this geometry question here. They tell us about two cyclic quadrilaterals that are in here, QU, and then SR, and then another one, QR and TU. And you're going to look at both of the long, skinnier quadrilateral, the bigger, fatter one up here, and they tell you something else. They tell you that QU and RT are parallel. They tell you this angle here, ROU, this angle at the center is equal to 2x. And then they ask you to find, giving reasons, 5 other angles equal to x. Well, if that's 2x, that's an angle at the center. Hey, this angle T opens up to the same UR thing. It must be x. And what was that reason? Angle at the center, 2 times the angle at the circumference. Now look at those parallel lines. That's the corners of an F there. U3 and T are corresponding angles. So U3 equals X, corresponding angles, because RT is parallel to QU. But doesn't T, this angle X here, open up to the same RU? The same RU, isn't that angles in the same segment? So that's got to be X, angles in the same segment. 6 marks and 3 x's done. Let's see if we can find another one. Look at this cyclic quadrilateral here, QUSR, that one there. Isn't that angle QT? Doesn't it have to equal this x? I think it does. Q2 has to be x. That's the exterior angle of a cyclic quad. Well, doesn't this one here, isn't there a cyclic quad QUTR? And isn't this angle here QRT? Right there, QRT is equal to x. QRT has to be equal to x, not QRT. QRS has to be. This whole angle in here has to be equal to x, because QRT has to be equal to x. Oh, yes, no, QRT has to be equal to x. That's right, because of this exterior angle. Q2 equals x because of the exterior angle, but then there's the fatter cyclic quadrilateral, QRTU, and that U3 is the exterior angle right there. So that works. Now the next question is, prove that ROUP, that you could put a circle around these. Well, there's 3 ways you can do it. You can have angles in the same segment. You can have an exterior angle working. But if we're going to get P and O, hey, look, we've got 2 x's here. If we found angle P, doesn't it equal 180 minus 2x, angle sum in a triangle? And then these opposite angles in a cyclic quad, they're adding up to 180. And that means that ROUP must be a cyclic quad. So first you say P is 180 minus 2x, angles sum in a triangle. And then you say ROUP is a cyclic quad. Why? Well, it's the converse of opposite angles in a cyclic quad. That's why we know we can put a circle around.